At this time, I'd like to introduce the facilitator for tonight's session, Dr. Keith Storey. Dr. Storey is the former head of the Department of Geography at Memorial University, and he has wide experience in environmental impact assessment and impact management. Two of the areas in which he has specialized have been the design of impact management strategies for large projects in remote areas, and the impacts of commute work systems, often referred to as fly-in, fly-out, on workers, their families, and their communities in mining and oil and gas sectors. He's also published widely on these and many other areas. Please help me to welcome Keith Storey.
Thank you, Morgan, and I too would like to welcome you here this evening. As you know, Husky Energy plans to extend the White Rose field. The Canada, Newfoundland and Labrador Offshore Petroleum Board has the responsibility for reviewing and approving Husky's application to do so. And as part of that approval process, the board is looking for public feedback. To that end, the board has asked the Harris Centre to undertake three main tasks. And the first of those is to facilitate a number of public information sessions, of which, as Morgan said, this is the fourth. Two have been in Placentia, two in St John's. And at those, Husky has and will provide a briefing on what the White Rose Extension project is all about, and to provide you with an opportunity to ask questions of Husky about the project. The second role for the Harris Centre is to host a website where members of the public can access information about the project, where they can ask questions about it, and post their comments on the project. On your seat there should be, hopefully was, a card with the website information on it. And I will return to say a little bit more about the website in a moment. As you can see in this diagram, Husky has prepared a number of key documents as part of their application. Those documents include the Benefits Plan Amendment, the Development Plan Amendment, the Socio-Economic Impact Statement Update, and the Wellhead Platform Concept Safety Analysis. Those will be the focus of our discussions this evening. You can download those reports and a summary document from the website, which has been created for this process. And as well, I believe there are some hard copies of the summary report here in the room this evening. You can also obtain a hard copy of any of the reports free of charge by making a request through the website. After the public information sessions, there will be a 90-day period in which members of the public can review project documents and post their comments. After which the second role for the Harris Centre is to host that website, but after which the third component of the Harris Centre's job is to compile a summary document of what we heard at these public information sessions and what people said as part of their comments on the website. And we'll prepare that summary document. That document will be submitted to the Canada, Newfoundland, Labrador Offshore Petroleum Board for their consideration as part of the review and approval process. So that's a 90-day process for review, and then there's another 60 days in which we can prepare that report. And the website where you can offer those comments, this is a page from the screen capture of the page from the website. The address is given both there and on the card on your seat, And as indicated before, you can access more information about the project from the website. You can ask questions and post your thoughts and comments. You'll also be able to see comments and thoughts from others. And so there's an opportunity for some interaction among those people who engage in this review process with respect to their thoughts about the project. So now I'd like to move to the first of the two main components for this evening's activities, and that is to invite representatives of Husky Energy to brief us on the project. The main presenters this evening will be Richard Pratt on my immediate left, who is Vice President of Development for Husky, and on my far left, Derek Piercy, who is Project Manager for the Graving Dock and the CGS. There are also a number of other Husky personnel here who are available to respond to particular questions as needed. I'd like you to hold your questions until the presentation has been completed. That presentation will take approximately an hour, but once the presentation is over, the floor is open for questions from everybody. So thank you for coming once again, and please welcome Richard Pratt from Husky. Thank you.
Thank you, Dr. Storey. Hello, everyone. My name is Richard Pratt. I've already been introduced. I'm the VP of Developments for Husky here in the Atlantic region. Derek Piercy, who is the project manager of the Graving Dock and CGS, which I won't describe what those are at the moment. You'll learn more about those as we go through the presentation. He and I will tag team the presentation today. I also have some of our technical folks here sitting in the room with me, and I'd like to introduce them briefly. So if you just please stand up when I call your name. Reg Bennett, he's the Project HSEQ Manager. Margie Allen, who is the Manager of Admin and Regulatory Affairs. Kathy Knox, who is the Senior Regulatory Benefits Advisor. Dennis McDonald, Subsurface Manager. And then finally, Dave Pinzett, who is our Environmental Advisor. So thanks for having us here today. We look forward to discussing in some detail our project with you. And I'll just click to the agenda on our discussion today. So what we'll go over is shown here on the slide. We will quickly go over a regulatory overview, and then we will talk a little bit about Husky, and not only who Husky is globally, but also a little bit about who Husky is in the Atlantic region, just to give you an understanding of who we are, the experience we've had, and what we've done here in the region. And then we'll also talk briefly about the different components of the documents that have been prepared that form the basis of the development plan that we've submitted, and we're seeking approval through this process. So as an introduction, this is what the field looks like today. We're going to talk to you about some things that we are recommending to be done in the field and some of the things to be changed. You'll notice in the exhibit on the slide, you'll notice the FPSO sits in the center, and then there's an offloading tanker immediately behind that vessel to the right, which is how we offload crude when the crude is produced onto the FPSO. Another thing that I wanted you to observe from it is that you'll see these subsea drill centers that is where our wells are located. So the wells are located in those subsea centers, and they flow back through pipelines back up to the FPSO. And the reason I mention that, when we show you the wellhead platform and what we intend to do with the wellhead platform, it's different. We're doing something different. We'll talk some about what we're doing different, what we're doing different and why we're doing something different. So before we get into that, I'd like to go through a little bit of the regulatory overview. Dr. Storey has already mentioned a little bit about that, but I'll hit this real quickly for you just to make sure that you understand who regulates us and what this process is all about. So the CNLOPB on the left, we politely call them the board. They do regulate the oil and gas activities for the province, and we are progressing this application through their coordination. And there's numerous documents that are available on the website that we have prepared. Those documents have been deemed complete. And to be clear, deemed complete means that they meet the requirements. They feel like they're complete to commence this process. So they're not deemed complete for approval. They're deemed complete for this public review process, which you're currently part of. The EAs, we'll talk a little bit about those, the environmental assessments. Those, we were released from the environmental assessments last year. So we have two of those. One is a provincial one, and the other one is a federal one. So we have been released from those. We won't spend a whole lot of time talking about those today, simply because we're already out of that process. So what are we doing? Why are we here? Why are we having all these sessions? What's Husky requesting? If you'll see the slide that's up, what we're looking at doing is developing the western portion of the field. The current development of the White Rose field has been the South Avalon area. That was the original primary area of the field that was developed. We have since extended the field to the south by the North Amethyst field, or extension, and also we're in the middle of the South White Rose extension, the most southern extension that we've done of the field. We did roughly half of that extension last summer, and we're in the middle of doing the second half of that extension this summer. Those extensions, as I mentioned earlier and showed in the previous picture, are subsea. So there are wells drilled in subsea drill centers, and those centers are tied back to the FPSO. We're doing something different in the West White Rose, and now we'll start talking about some of what we're doing different. The public review process, I think, has already been mentioned. We're in the 90-day window, public window of review. Your comments, both that are submitted on the website, submitted in these sessions, this being the fourth of four. And then the report will be prepared by the Harris Center. It'll form the basis of hopefully a recommendation by the board to the governments to approve our development plan. We would anticipate that approval, assuming our process goes forward smoothly from this point. We would anticipate that approval later this year. So a little bit about Husky and what we are and our global operations. This slide here shows you that we're a very diversified, spread across the globe, actually. We have three major areas of activity. One is in Southeast Asia. We call it the Asia-Pacific region. And then we also have a strong position in the Western Canada and in the oil sands, which is another major area for us. And then thirdly, the Atlantic region here is another area. Our company calls those our three growth pillars: the Atlantic region, the oil sands, and also the Asia-Pacific region. What does that mean? It means it's the main engines that we are currently progressing as a corporation to grow our company. And this is one small piece of that, what we're talking about here today. And we'll talk about some other parts of that that are also going on in Eastern Canada. So now we'll focus in on Eastern Canada. Where's the White Rose Field? Well, it sits offshore about 350 kilometers east of St. John's in 120 meters of water. And it's on the Grand Banks. And you'll also notice, if you look at this slide, that the current fields that are producing and being developed all sit in relatively close proximity to each other. So you can see those highlighted on the slide. So a little bit now we'll get a little more specific into the White Rose field and talk a little bit more about that field. Obviously, that's what we're here to primarily discuss today. It is a Husky operated asset. The project was originally sanctioned. What does that mean? It means we received approval after regulatory approvals. That's when we received approvals, we being the companies investing, the stakeholders investing in that field received their approvals to move ahead with major capital investments to put the field in or develop the field. So that was in 2002. First oil occurred in 2005. And you can see on the slide we've produced 224 million barrels of oil from the field to date. An interesting tidbit is that that's roughly what we sanctioned the field for. So good assets normally get better, and White Rose Field is a perfect example of it. And of course, we're going to be progressing a development that we hope will significantly add to that number. I'll talk about those numbers in a minute. The two extensions, I mentioned the extensions to the south, North Amethyst, May of 2010, a $2.8 billion development. South White Rose extension, 2013, we put in half of it. And then this summer, we're putting in the second half of it. But again, these are subsea extensions. We also have several other things going on. We're a partner in the Flemish Pass discovery with Statoil. You can see it here on the slide. We also have recently signed a 5-year contract on the West Mira, which shows it is a new build rig that's coming hopefully this next summer to the region to drill wells in the basin. So I can't talk about activities without talking about safety. Safety is an important thing for Husky. So you can see here the 14 elements of our operational integrity management system, something that we're very proud of, something that we spend an awful lot of time on. So it just, I guess in a nutshell, it basically just tells us, gives us the direction or the things that we live by when we're producing an oil and gas asset. So it gives us those guiding principles that become part of our daily life. Another thing that's a very important part of it is not only how we deal with our daily operations, but it's also gives us guidance on how we design our facilities. And so we call that process safety. And that's something that we incorporate into our day-to-day design. So when we're looking at building something, which obviously is what we're here talking to you about today, it gives you the guidance on the process safety, how we build that into something such that it will be operated and will function properly for the safety of our environment, people, etc. So now we'll move a little bit into, okay, I've talked about subsea centers. I've talked about those being tied back to the field. Now we're going to build this thing that's shown on the left-hand side. We call it politely the wellhead platform. It is comprised of a concrete gravity structure. That's the lower portion of it. And then the top sides, which is the portion that sits above the water, that you can see above the water. And it actually is a fixed drilling rig. So there's a rig there, and we'll be drilling numerous wells from that facility. It is a fixed facility, and it is also sits on the surface. So there will be living quarters on it. There will be people living on it. And a key difference, as is highlighted on the slide, is there's no oil storage in this facility. So the current facilities that exist, Hibernia, for example, Hebron being built, they have oil storage or will have oil storage. We have no oil storage. Why? Our oil actually transits over to will transit over to the FPSO, and it will be processed on the FPSO. We don't need additional processing facilities. We don't need additional storage. It's already there. So that is a distinct difference between what we're doing and what the other projects are currently working on. Why do we do this? Why did we build a wellhead platform is an obvious question. And this slide articulates the primary reasons why. We looked at this hard when we were first looking at the development, and we believe that we'll recover substantially more resource, i.e. oil. We'll generate more revenues for the province by doing that. This facility will also facilitate more or less interruptions to our operational activities on the Grand Banks. So we'll be less weather sensitive when we have a fixed structure sitting there versus if we're sitting on a floating vessel. Because when we do the subsea drilling, we're sitting on a floating vessel. And so weather conditions, we're way more susceptible to weather conditions and downtime based on those weather conditions. So you can see the two graphs here. The one on the top shows more hydrocarbons being produced, more oil being recovered, i.e. generating more benefits and we hope more value. Obviously, the wellhead platforms, just to be clear, are not a new concept. We're using it a different way here on the Grand Banks. Our plan is to use it a different way, but these are proven concepts. The wellhead platform is a proven concept. It's been used around the world for a long time. Size of the wellhead platform, I don't know if you can read the slide, but it's 254 meters on the slide, and you can see how that compares to the Calgary Tower immediately to the left of it on the slide, Empire State Building. So 254 meters. It's a very tall structure. Another thing that we like to talk about is the schedule. When are we going to do all of this? So we have commenced construction of the graving dock, and we call it an early work. I'll reiterate, the project has not been sanctioned. We do not have full formal approval to do the project yet. We're progressing part of that process here, but we did get approval to kick off the graving dock down in Argentia, and basically it's the large hole in the ground where the graving dock will ultimately be built, and that has commenced construction and is currently ongoing. Upon seeking approval of the development plan in late 2014, we would then kick off the construction of the CGS. Again, that's the structure that the topside sits on, and then the construction of the topsides. Then we would go through a significant amount of work being done in the summer of 2017, which is when we envision taking the CGS to the field, also bringing the topsides to the field, mating them, in other words, setting the topsides on top of the CGS, and then getting that facility up and running to commence drilling late 2017 and hopefully start drilling our first well. So it gives you an idea of the schedule, what we're trying to achieve with our timeline. Now I'll turn it over to Derek and let him talk about the development plan and the benefits plan.
Thank you, Richard. Okay, so what is it we're doing? Well, there's 4 major scopes for the wellhead platform project. Graving dock construction. Once the graving dock is completed, we'll be building the CGS totally in the dry in the graving dock in Argentia. We have topsides facilities, and of course the marine, which is a bunch of scopes put together and labeled under just marine. Each of these scopes have significant benefits for the province. So the construction phase, project benefits, project management, the White Rose Extension project. Management team is located here in the province. Full and fair opportunity. We have a commitment to provide full and fair opportunity for consideration to local suppliers and first consideration. Supplier development will arrange supplier forums so the local business community can learn about procurement opportunities. And procurement and contracting, the procurement offices of Husky and its contractors will be located here in the province. Husky and our contractors are committed to the principle of first consideration for the residents of the province to be employed on the project. We will identify and develop programs related to industry. We also understand that there are certain skilled trades that are difficult to get just due to the competitive market. So we are, we'll work with our stakeholders, and we'll put off short-term training programs as required to gain those skills if we need specific skills for the project. We also hire work-term students. We cooperate with the MUN Engineering Co-op program. Currently, Husky has a total of 39 work-term students hired, and 6 of those students are working directly for this project. So the project will have a number of employment opportunities, both directly and indirectly. And here are some of the more major, probably heavy-hitting skills that we will need from engineering, technical, through the skilled workers. We are confident that we can build the required workforce required to execute the project here in the province. So approximately 68% of the total person hours associated with the development of the project will take place in the province. When you add all that up, we have total Newfoundland engineering, construction, and marine hours of almost 5.5 million person hours. So the graving dock is the first step in our project. This was tendered last year and awarded to a contractor in October of 2013. Work has been progressing through the winter. Obviously, it's been a very challenging winter this past year, but we are making good progress. The site is excavated behind a natural coastal berm separating the ocean. It is the blue dotted box there is the area of the graving dock that we are excavating, and it measures about 172 meters by about 148 meters. Just to put in perspective, that's like 6 football fields total area. So it is a fairly large dock, but it is what we require certainly to get the CGS out once it's constructed. So we got to move a lot of material, a lot of excavation, up to a tune of 1.4 million cubic meters of material, quite a lot of material. So once all that material is out of the hole, we have a big hole that we need to control water. So we have a total of 83 deep well pumps that will be installed to help control surface water and groundwater. But also we need what's called underground cutoff walls. These will be soil cement bentonite walls deep underneath the surface to 28 meters in one location for the cutoff wall for the C-bund, and another wall which will be 40 meters deep under the ground for the dock gates, which I will talk about in a moment. So benefits for the Argentia graving dock. Obviously the reusable dock gates. These are permanent infrastructure made from concrete, which is reusable, so there could be future projects in this particular dock. We have done site infrastructure upgrading already to date. We've brought in water, electrical power, high-speed internet, for instance. There's opportunities for Newfoundland workers and companies right now on site. Presently, there's well over 100 people on site, and over 75% of those are Newfoundland and Labrador residents. And also in the area, there's about 30 local companies supplying the project, plus spin-off benefits. So you can imagine as people that are down there working on construction, they're buying gas, they're in the restaurants, hotels, renting houses, etc. So a bit on the dock gates. As I stated, these are permanent infrastructure for the graving dock. The total opening width of the dock gates is 148 meters. Try to put that in perspective, the Scotia Centre downtown, many probably are familiar, would take about 3 of those on its side, end to end, to plug the width of that dock opening. So these gates are a very significant piece of infrastructure. 25 meters high, and a total volume of concrete, 22,000 cubic meters. So really a project in itself. These dock gates are not being constructed with the graving dock contractor, but will be constructed by the CGS contractor, which will be awarded later this year. So the CGS, it's basically the base of the facility. The concrete structure will be built totally in the dry in Argentia. It'll reach up to almost 136 meters, and it will be brought offshore and is the base for the topsides, which will be installed later. The mechanical outfitting is what we call all the steel structure, components, piping, and so on that is inside the shaft. It's almost the circulatory system for topsides. We need to get fluids from topsides to the C-rows and C-rows to topsides. And we also need facility for drilling. So that's what the drilling conductor guides are for. So the majority of that mechanical outfitting will be fabricated in the province. And all in, we're looking at about 5 million person hours in Newfoundland and Labrador. So the topsides, which goes on top of the CGS, is a fully integrated structure. The deck area is about 40 by 72 meters. The facility will include the drilling facilities, but also we need utilities. So that's power generation, fresh water generation, compressed air, those types of things. There will be well testing, which is a regulatory requirement for the facility. Metering, we need to measure flow, and we're designing the living quarters for 144 people on board who will work on the facility. The fabrication work is being bid internationally. The tender invitation to bid was actually issued on March 31st. There are 2 provincial yards that have constructed and fabricated large topsides modules. But just for information, both of those yards today are under contract to another project. There are, however, 4 major local components on the topsides that will be fabricated in Newfoundland and Labrador. They are the lifeboat stations, the living quarters, the helideck, and the flare boom. These 4 items altogether would contribute to about 200,000 person hours of work in Newfoundland and Labrador. Husky has already gone ahead and tendered the living quarters as well as the helideck due to schedule. We want to get that out a little bit early. It's some major work that we wanted to get moving. The lifeboat stations and the flare boom will be tendered by the topsides fabricator, whomever that is, at a later date to a Newfoundland company. The final scope of the project is the marine operations. So it is, as I mentioned before, made up of several scopes. One is, once the CGS is completed in the graving dock, we will remove the C-bund, remove the dock gates, and we'll bring out the CGS and we'll tow it to the field, which is about 350 kilometers east of St. John's. The topsides, we do not know yet where it will be fabricated. Again, it is a global tender, but there is a marine component to ship the topsides from that yard, wherever it is, to Newfoundland. When it comes to Newfoundland, The topsides will then be transferred to a brand new vessel, the largest installation vessel in the world, called the Peter Schulte. The Peter Schulte has the ability of bringing this topsides from Newfoundland offshore and installing the topsides on the pre-installed CGS base, which has already been taken out at that time. So a little bit on the Peter Schulte. It has over 240,000 tons displacement, 382 meters long, and 571 POB. This vessel is being built by a company called Allseas, and by all means you can Google their site and you can get more information, pictures and video on this new vessel. We have a short animation here now which kind of summarizes a lot of the things that we've been talking about of the wellhead platform, but hopefully will give you a good appreciation regarding the construction, how it comes together and gets offshore.
For over 30 years, Husky Energy has been a leading explorer and developer in the Newfoundland and Labrador oil and gas industry. Building on the success of its current operations in the White Rose field, Husky, along with its co-venture partners, has commenced the planning and development phases of the White Rose Extension Project. This project will be developed using a wellhead platform, which will be tied back to the Sea Rose FPSO. The wellhead platform will serve as a fixed drilling rig and will be located approximately 350 kilometers southeast of Newfoundland and Labrador, in the White Rose field. Construction on the concrete gravity structure, or CGS, is taking place in Argentia, Newfoundland, located 134 kilometers from the capital city of St. John's. The Argentia site covers an area of 50 acres. A significant engineering feat, the construction of the graving dock and the CGS will require approximately 5 million person-hours. Excavating a graving dock is the first step, which begins with the construction of the cut-off walls, deep underground walls that protect the dry dock from ocean waters. An integrated dewatering system controls water in the graving dock. Cranes will then be erected and slip forms used to build the concrete structure. Once complete, the CGS will stand 136 meters high, comprise 7,300 cubic meters of concrete, and contain 3,500 tons of mechanical outfitting. 148-meter-wide concrete dock gates will allow the graving dock to be reused in the future. Once the CGS is complete, the dock gates will be removed and towed away from the dock. Tugboats will then transport the CGS to the White Rose field, where it will be installed on the ocean floor. The topsides will be an integrated structure consisting of drilling facilities, accommodations, utilities, a flare boom, and helideck. There will be a cellar deck, middle deck, and drilling deck constructed at the same time, which, when completed, will be joined together. Once the topsides are finished, they'll be transported to Newfoundland waters. The topside structure will then be transferred to the Peter Schulte, the largest platform installation vessel in the world. It will carry the topsides to the White Rose field for installation atop the CGS. The technology behind the wellhead platform is the first of its kind in this region and will help open up new options for field development. An important step in extending the life of Newfoundland and Labrador's oil fields, and in creating opportunities and benefits for all.
So I hope the video gave you a little bit better understanding of the complexity and how the things that we're talking about tonight all fit together. So I think it helps us all just to look at the whole process and understand that it is many facets and a significant piece of work. So I'll move on now into our next section and talk just a little bit about the subsurface. We've really talked up to this point about what goes above the seabed, the stuff we're building, and we'll talk a little bit now about the subsurface. We'll talk about where the hydrocarbons are coming from that we'll ultimately be producing or intend to produce. So we talked about that we have existing production. We talked about the production that's already been produced from the field. That has been produced from some 34 wells that we've already drilled that are producing back subsea. And those wells are located in the South Avalon, the North Amethyst tieback that we've already talked about, and then future wells will be located in SWRX, which is the southern tieback. So we're looking at developing, again, as I've already mentioned, the West White Rose. So we're going to be primarily drilling wells to produce the oil that sits in this region of the field. So how many wells are we going to drill? I just mentioned we've drilled 34 wells in the field. Our base plan is to drill 38 wells from the wellhead platform. So we have the capability to drill 40 wells. So basically we're going to drill, in the base development plan, we're going to drill 38. I would anticipate a high likelihood that we'll drill every well that we can possibly drill from the platform, which would be 40. We're going to have roughly half of those wells are going to be producers, and the majority of the rest of those wells will be water injectors. So we're going to be producing hydrocarbons out of the reservoir, and then to replace voidage in the reservoir. Many times, from a reservoir management perspective, we inject something back into the reservoir to maintain reservoir pressure. In this case, we'll be injecting primarily water. We will also be re-injecting the gas that we produce from the field. Relatively moderate resource quantity here. 115 million barrels is the amount of oil that we anticipate recovering from those some 38 wells that I just mentioned. So it's just a reminder to me, we're talking about big investments for our facility, and we're talking about relatively moderate resources. So it reminds me, and I frequently remind the team the discipline that we need to have executing the project, because we need to be disciplined on both our cost and our schedule to achieve recovery of that kind of oil and ultimately make money on it. Drilling safety systems. The good thing for us is we've drilled a lot of wells out here in this field. So we know the field very well. Our technical people know it well. Our subsurface folks know it well. Our drillers know it well. We understand the pressures that we're dealing with. We're very familiar with drilling wells here. That's a huge advantage for us developing this field. In addition to that, we have the luxury of building our own facility with a rig on it, and then the required safety systems that we believe need to be in place to ensure that we have a safe operation. So that's something that we're incorporating into the design of the topsides, including the rig itself. The platform design, again, we're designing it as well. This is an embedded animation on the side. We as engineers do a lot of work. We do a lot of calculations, trying to decide how something should be built, use past experiences, etc., do a lot of analytical calculations and actual computer simulations. In addition to that, what we will do is shown in this animation. We will build models, and then we will put those models in a tank. This test here that was just shown was actually run up here at the college, of the university. And it was actually our second wave test of the facility to try to understand how that facility will respond and react to adverse weather conditions. So it helps us design a safer facility. We've talked about a lot of the benefits. I'll hit the operational benefits here real quickly. So we've got a lot of activity going on during the construction phase. We're going to be building a lot of stuff. We're going to be building a lot of these things that Derek's just talked about. And in addition to that, we're putting a facility in place that'll be there for years to go into the future, 25 years into the future. So we're creating permanent jobs on that facility. So there'll be 288 permanent jobs on the facility. And then we will also have significant direct and indirect employment associated with additional people being employed to support that ongoing operation, which will go on for years. And then we'll also have specific drilling activity going on. As I mentioned, it's a drilling rig, and then it's also going to be a producing facility. So we have 18.5 million operating person hours that we've calculated as an estimate of what that number would be, a significant number of person hours. To operate that facility, obviously there's additional benefits to the local area, and you can see some of that articulated here. There's a lot of services listed here that will need to be provided by the local area, and a lot of those are listed on the lower portion of the slide. We also talk about the employment and estimates of where the majority of those people will be employed or come from that are being employed. So you can see the 90%, and they will create long-term career opportunities here. So the point is, this isn't just a construction exercise, even though we're very focused on construction in the next few years until we can get this thing in the water and get it functioning, but it'll be here for a long time.
Okay, next we'll look at the socioeconomic impact statement and sustainable development report, which will be referred to as SEIS. The SEIS looks at the potential impacts of our project on the local communities. So the positive effects, is expected to contribute positively to employment, local businesses, increase government revenue, and develop technical expertise and skills in the province. The Argentia, Placentia areas and St. John's will see increased direct, indirect, and induced benefits. Negative effects expected to be minor in nature and within capacity of existing services. There's one area that we're continuing to monitor, and that's the housing requirement in the Placentia area. Once we have a contractor on board, we'll know, more definitive of the construction schedule and the number of people and the peak manpower demands, person power demands we'll have in Placentia. And, we'll continue to monitor that to ensure that we have sufficient housing. Next is the concept safety analysis. The purpose of the CSA is to identify risks of the development. Risks associated with the White Rose expansion project are similar to those of the operating field White Rose. We have extensive safety plans to mitigate these risks and prevent occurrence. We've been in the field now since 2005, so we have very extensive experience. There was no areas of concern that would prevent us from reducing risks to what we call as low as reasonably practicable. The CSA is the first analysis of the safety of the wellhead platform. The CSA is completed at the front-end engineering design stage. So once you have the concept developed and you're doing a little bit of detailed design, you'll do this as a first safety study. That feeds into your future design work for the program and also will form the basis of the platform's operation system safety plan. As noted earlier, we've been released from both the provincial and federal environmental assessments, but we do have just a couple of slides here to show you briefly what was included. So the environmental assessment looked at the project activities from the graving dock construction, CGS construction, right to the installation in the field. Husky consulted with all levels of government and stakeholders and public, including the following that's listed here on the screen. The assessment included a wide range of areas as listed. Findings, routine project phases and activities not predicted to have significant residual environmental effects in these areas. If anything out of the ordinary happens, that could have an effect on marine birds, but we have processes in place to mitigate and avoid such occurrences. For the operations phase, the platform will have a specific environmental protection and compliance monitoring plan for the life of the project. Okay, we have that really concludes the DPA portion of the presentation. There is another video here that we'd like to show. This video was produced last year by our offshore folks to give the onshore Husky folks a little bit better appreciation of what it's like to work offshore on our FPSO called the Sea Rose. As you'll see in this video, and I will just narrate a little bit for you, you'll see a lot of safety practices and procedures, but more importantly, the people actually doing drills and practicing those things, not just simply documents that are written and not looked at again. So if we could just give that a roll. So this is a permit review meeting, reviewing any work that's going on that day, and the proper authority signing off on that work. We have a lockout tagout procedure offshore to isolate any energized equipment, and the electrician here is just demonstrating that. Toolbox talk before every job. The guys will have a toolbox talk to talk about any hazards associated with the job, environmental conditions, and to make sure they put in place any mitigations so the job can take place safely. We have skilled workers who can work at heights offshore. Safety observation system offshore, so if you see anything that's safe that everybody should know about or something that's unsafe that everybody should know about, you fill out a card that'll be shared with everybody on board the vessel. The electricians here are donning what they call some high-calorie suits as a preventive measure while doing work in the switchgear room. Here's one drill that we talked about earlier, and it's a man overboard drill. This is a mannequin. So he's tossed off. The fast rescue craft then will retrieve the mannequin, get it back to the standby vessel, the supply vessel, which will then transfer the mannequin on the frog system back onto the Sea Rose. This particular drill took a little over 3 minutes to complete. Just taking a water sample. Here's another drill, is a man down drill, just practice ways of transferring to the board back to the clinic. Shot of our control room and now into the galley. Yes, every Friday night is bingo night.
So hopefully that gives you a snapshot of what living and working offshore is like. We hope you enjoyed it. So anyway, I'd like to just wrap up by saying how excited Husky is to be working the project that we're currently working on. We're excited about the potential of the project. We're also excited about the benefits that it will generate, we hope, for the province as we go forward with our approval process. And that concludes our formal presentation session.
Thank you very much, Richard. And Derek, thank you.